Okay, hello again and welcome to the next video. All right, this video is consistently made just to be an accompanied evaluation on the previous video. Okay, on the previous video, we solved the sensitivity analysis by using the graphical methods. Okay, we are focusing on the Giappetto problems. If you want to know more about the Giappetto problems that we consider in this problem, you can refer back to the video one on this linear programming series. Okay, so what we are focusing now is just on the solving of the simplified version of the mathematical modeling equation based from the earlier problem in video one. Okay, so um, now we start to look at how can we solve this sensitivity analysis by using a software. Okay, in this case I'm using QM for Windows. It is not limited to this software. Okay, I would like to emphasize that because in the world out here, especially in this open era, you can always find different source of programming as long as it works. Doesn't matter. All right, so to make it easier for us to discuss a little bit more on the utilization of your software, we use the QM for Windows. Okay, I give you a brief idea first about QM for Windows. Okay, on your left hand side you can see this is all the template for this particular software. Left hand side, it has a lot of different functions, okay, for you to consider if you have different other problems. If let's say you want to look at the game theory problem, you can use on the left hand side. If you have a little bit more extensive problem and you want to use goal programming, okay, you can refer back what is goal programming. In a way, you can use these problems there. And then the scoring model, the simulation, the statistics, okay, the simple distributional statistics value, so you can also use it over there. But what we are focusing right now, I'm going to look at the linear programming because this is the problem that fits with our solution for our Geopeto problems. All right. So first things first. Okay, since this is in for you guys who the first time you see this QM for Windows. Okay, you have the function over here, new. All right. In this case, you refer back to your problem. I recommend you write down somewhere on your Geopeto problems. Okay, you have actually you have two variables and you have three different constraint. Okay, I did not put also the final constraint of the positivity. Okay, a non-negative valuation because we consider that we are talking on the production type, so we are looking at the quadrant one. So basically we can assume that all is positive, okay, for our variables. All right, so we can start by getting the title first. Okay, I just put Giappetto. All right, Giappetto problems. Okay. All right. And then now over here, it is a well-defined template already. So you can just put your number of constraint. In our case, refer back. You have three number of constraint. And then what about number of variable? You have x1 and x2. Okay, your x1 is actually for soldier wood, and then your x2 is for train wood. So number of variable 2, just leave it as it is. And then actually you want to maximize, all right, your production for your soldier wood and also your train. So your objective function, put in a maximum, okay, maximize solution. And then the modify default title, just you can change later on. So just put constraint 1, constraint 2 and constraint 3. Okay, and then you get that. See, automatically you have this particular template for you to use. And in this case you can change your, oh sorry, you can change your x1, just put it as soldier, and then your x2 put it, sorry, your x2 put it as train wood. Okay, and you have to maximize that with your constraint. You can put as the first one just now we have the finishing time, and then your constraint 2 you have carpentry time, carpentry time, and then your constraint 3 is just your demand. Okay, your demand. All right. So now it gets interesting. Okay, so now we can start look at our subject 2 problem. Okay, meaning that your constraint. Okay, so this one you need to be very careful. Put the value over here. In fact, on your upper side, you have the instruction there. Enter the value of maximize for soldiers. Okay, for example, blah blah blah. You can read that. So you can just simply put your soldiers as 2. Your train now just 1. So you can see over here, your equation form right now becomes like that. Okay, and then the similar ways for your constraint 1. So your soldier 1, and then your train now becomes 1. Sorry. Yes. And your right hand side, meaning that your valuation there just now. Sorry. This one is actually maximum, okay? But the maximum objective value. So this one, you have to maximize your 3 for soldiers and 2 for train. This is your constraint. Be very careful to put the value over here, and then one is clear. This is your right hand side value. In this case, your limiting values is 100, and we do the same for your carpentry. The one for soldier, one for train, and then your right hand side value right now is IT. Okay, so you can see over here all the equation form will go accordingly according to what are the inputs that you put inside. And then this one, your x1 only, you consider your 3 is just 0, your demand doesn't matter, and then your right hand side now equals to 40. Okay. All right, so this is it. Okay, so this is it. Okay, so how can we solve this? Okay, so remember a bit, our intention is actually to focus on the sensitivity analysis first. Okay, so I'm going to discuss on the sensitivity analysis. But before we discuss on the sensitivity analysis, we need to solve this, correct? Okay, so so that we have some idea which part would be our optimal values, all right, and optimal solutions. Okay, so you just go into your solve panel. Voila, you get the solving value. See over here, your solution here now. You have in the optimal solutions is 180. Your optimal soldier value is 20, and your optimal train value is 60. It's 100%. It's straightforward, right? You don't have to construct your line anymore. Okay, that is why I say it is very easy for you to solve by using a software. It's like a shortcut for your misery. Okay, so but since we are talking now about the sensitivity analysis, I'm going to show you the one that we discussed on the previous video. Actually, is just concluding in this ranging. Okay, ranging value. Okay, I put a little bit bigger so you can see a little bit better. Okay. Eh, okay, sorry. Okay. Okay, I should start from here. Okay, this is the value. Oh, sorry. Okay. This is actually the value, exactly the value that you can get from your graph, your messy graph earlier. Okay, so this is the slack and surplus. This is your lower bound and your upper bound. Remember the lower bound referring to your finishing time. Okay, if you can tie back to the original video just now, remember your finishing line. Okay, your right hand side value when you reduce your finishing line into 80. And then it will reduce at the bottom of it, but it does not uh, it cannot get less than 80, and then your upper bound is 120. Why? Because you remember earlier, if you put upper bound more than 120, it violate the demand valuation on your right hand side just now. See, you can see over here, you put poop and you can see all this valuation is just reflective of the valuation that you have earlier. So ranging in this case is your sensitivity analysis. So you can see how it goes about it, and you can look at this particular software. At the same time, you can look at the previous graph that you have, and you can see which would be which. Okay, so that is the concept of sensitivity analysis. Okay, that one is done. Okay, so our objective for today on QM window is done already. Okay, this is another additional information for you if you would like to know more. Okay, you notice, okay, this solution over here, there are lots of different solutions there, right? Okay, you have linear programming results is the one that we have earlier, and then we have ranging. Okay, and then we have the solution list, the iterations, the dual, and the graph. Okay, is already in over here. This is your solution list, for example. Easy, isn't it? That's why I that's why I always like working with um machine. Okay, because it makes your life oh so very easy. And then in case you want to know about your iteration, doesn't matter, you can check this one, and then the dual. What's more important, okay, is this. Okay, see, they give you the graph. Where is the graph? Okay, I cannot get the graph. Okay, they will give you the graph. Oh, over here, sorry. This is your graph. Okay, sorry, I have two different okay, I have two different screen. Okay, all right, so this is your graph. Interesting, isn't it? So you, instead of using it doing it on your own, you get your graph already done for you. Okay, with all the values on your right hand side referring to all the information that you need, and then your ISO profit line is already lining up there, and then your values for your optimal solution is already taken care of. Okay, so this is how you solve your problems by using QM for Windows. So I hope you can play around with this one. Find yourself some of the questions that you have in mind, all right? Or if, let's say, you find the question from the books or from the internet or from whatever sources, and then you can use this QM4 window and put all the constraint and the objective function and solve. And you can see how easy it will make your life. All right, so I hope you enjoy the video and start exploring. So I'll see you in the next video.